Hello.
Hello.
Okay. Do you hear me?
I can hear you, Dr.
Okay,
Fatai.
good. Yes. Nice to meet you.
Thank you. You are welcome on board. Uh, I want to welcome all the participants for this Chat with Experts episode 2 from Institute of Data Science and Artificial Intelligence, Nigeria. So we will proceed directly to the webinar, which is tagged the application of data science in petroleum exploration and production. And with us here is Dr. Fatai Anifowose. He is a research scientist. He's a research scientist with Saudi Aramco, and his portfolio, his major job description is geophysical modeling and reservoir characterization using machine learning and computational intelligence. So from here, we are going to hand over to Dr. Fatai to proceed with the webinar for us. Before I hand over to him, I would want to encourage our participants to submit their questions at the chat room, so that we can read through and ask the presenter, the speaker, because if we say we should allow people to speak directly, there may be some kind of interference. My name is Yusuf Abdulwahid Adebola, and I will be your host for today. Thank you very much, Dr. Fatai. Over to you. Thank you.
Okay. Thank you very much. Do you hear me very well?
Yes, I can hear you.
Okay, good. So, good morning, everyone. And I'm very glad to be with you today. As introduced by our moderator, I've been invited to talk about application of data science and artificial intelligence in petroleum exploration and production. And to be honest with you, the outline of the talk given to me is much more than what could fit into the 40 minutes time frame given to me. So I've tried to condense the material a little bit, and I will try to be as explanatory as possible, at the same time getting the message across without moving too fast and without missing much of the material. But actually, I see the materials to be in two parts. The first part is the petroleum exploration and the production, and the other part is the application of data science and artificial intelligence. So in order to do justice with the time given to me, I have decided to reduce a little bit of content in the area of the petroleum exploration and production, because I think that is a little bit easier to catch up with. You can easily go online and read up something about it. Though I'm not skipping it altogether, so I'm just trying to optimize the material within the bound of time given to me. So in the next couple of minutes, I will be sharing with you. I will start with a brief introduction to the concept of data science and artificial intelligence and the associated technologies that go along with them. Then, of course, I will share with you some of the emerging opportunities that we are having based on the fourth industrial revolution and based on the digital transformation going through the oil and gas industry. Of course, there is no new technology without its own challenges. So I will share with you some of the challenges of the application of machine learning in the oil and gas industry. And of course, I will conclude with a few recommendations that will guide us as we navigate our path in this field. I hope I'm still very clear enough.
Yes, sir.
Okay, good. So we cannot be talking about data science nowadays and artificial intelligence without starting from the fourth industrial revolution. And before getting to the fourth industrial revolution, we have to start from the previous revolutions. So the first revolution came about in around 1784. And it was all about mechanization, steam, and water power. The second revolution came around 1870, and it was about mass production. And that was when progress was made in the area of electricity. The third revolution was about electronics and the computer systems, and that came around 1969. That was when the computer technology became very much widespread, and the grounds were gradually being prepared for the internet revolution. Now we are talking about the fourth industrial revolution. And this is what we are having today. However, the fourth industrial revolution is different from the previous ones in the sense that instead of coming with just one or two items, it came with a massive collection of different technologies. And that makes it very impactful. It is impacting our life. We are being faced with it in various areas of our life and our work life, and as well as our private life. We have AI algorithms running on our smartphones, in our television, in our cars, and everywhere around us. So the fourth industrial revolution is massive in its dimension. Having said that, then let's go into what exactly is data science. Nowadays, we begin to hear much of this, and people take one course or the other in data science. And if you're on LinkedIn or Facebook, you see people posting their achievements, having completed a course in data science. So what exactly is this? And as you see, it is composed of two words, data and science. We all know what science is, okay? And probably in the next slide or in the next couple of slides, I will explain briefly what data also is. But combining the two of them, we can say that data science is an interdisciplinary field that combines scientific methods, processes, algorithms, and systems. And it combines all of this to extract knowledge and insight from structured and unstructured data, and to apply this newly extracted knowledge and insight from the data across a broad range of applications. So in essence, we talk of data science, we'll be doing some elements of mathematics, statistics, we'll do some coding, and we learn about AI, machine learning, and of course, we apply all these things to solve one problem or the other. Now, before we move on, let's talk about the other aspect of the topic given to me, which is artificial intelligence. Now, what is artificial intelligence? I would like to hear from the other side of the of the room very quickly, just to make the talk interactive. Who can make an attempt of telling us what AI is all about? Feel free to unmute yourself and let me hear something from someone. Any volunteer? What is artificial intelligence? Anybody? So it's either everyone is muted or no one has any idea. Okay. Or someone is feeling shy to say something.
Please.
Don't worry. You don't have to be 100% correct. Yes, I want someone to volunteer to say something. You don't have to be 100% correct. Anybody? Okay, I will move on. Actually, there are various definitions out there. So it depends on which one you are more comfortable with. But this one is my favorite. It's very short and it makes a lot of sense. It says AI is the science and engineering of making intelligent systems. And this definition was by John McCarthy, a professor of computer science at the Stanford University in the US. And I will try to explain them. Now, the definition talks about intelligent systems, right? Intelligent systems can be in form of hardware, it can be software, and it can be a combination of both. When we talk about hardware intelligent system, we think about robotics, right? For example, a robotic arm that has been programmed to perform a specific set of activities that will end up, accomplishing a task. And a very simple example is a robotic arm that's been programmed to grab a bottle of Coke, fill it with a liquid, put a cork, screw the cork, put a binder, and then drop the bottle into a crate. This is an example of an intelligent hardware system. Also, it can be in form of software. Nowadays, we have very intelligent software applications. As I said before, some of them are running on our phones, some are running on our laptops, some are designed for specific applications. And sometimes we can have both of them combined. And a good example of this is some intelligent rovers, okay, ROVs that can be launched to go to some remote areas that are probably dangerous for humans to go, but you launch these robots there, and they have both the hardware and the software to analyze the environment, gather some data, take some actions, and return back. And a very good example is the robot that is currently gathering data and doing some data collection in a planet called Mars. Now, history is very important. We all like to know our history. We all like to know, how things that we are doing, how they started. AI has its own history, and it goes as far back as 1941, when the first electronic computer came into being. And this is because we have to trace the root of AI to the beginning of computer, because without computer, we cannot be talking about AI. So after that, in around 1949, the first stored program was developed. And in 1956, the words artificial intelligence, which we now call AI, was created at a conference in Dartmouth. And around 1958, a programming language called Lisp was developed and introduced. Around 1963, the American Department of Defense started an advanced research looking at AI and how it will impact our life today. And around that time was when the machine learning algorithm called neural networks was developed. And in 1970, the first expert system was developed, and another programming language called Prolog was also developed. In around 1986, artificial intelligence became commercial, and some companies started selling some hardware components that are infused with AI. In 1993, an AI program beat a human chess master in the game. And around that time was when AI started going into the military. And in around 2011, there was a massive launch of AI products by technological companies. You talk about Apple, talk about Google, Microsoft, and so on. And today we have much more of them, like Facebook, WhatsApp, Instagram, and so on. All of them are using one form of AI algorithms running in them or the other. And in 2013, we started hearing about deep learning. All of the some of this I will be explaining in few minutes. And then very lately, we started seeing very specialized hardware championed mainly by NVIDIA. Of course, there are other companies that are building special hardware, and on top of which specialized and more complicated software driven by AI are running. And on one of these hardware, we have an AI software called AlphaGo beating a human champion in the Go game. And also we have the Google DeepMind running on these algorithms. And nowadays we continue to see much more improvement by the day. So very quickly, now we have mentioned data science. What exactly is data? We can say data is a unit of information. It is an element of information. It is individual facts and statistics that are collected through observation. When you go to the hospital, before you see a doctor, the nurse will take some data from you. For example, the nurse will know your height, your weight, okay, your body temperature. So each of these items is called data. But when we combine all these elements together and they make sense all together, then they become information. They become something that gives us, that gives some sense. And within the realm of petroleum exploration and production, we have basically two types of data: structured data and unstructured data. And the main difference between them is the way they are organized. Structured data is any data that you can arrange in form of rows and columns. You have the columns, starting with the column header. So the column header tells you what the column is all about. And you have the rows. The rows is giving you a complete set of all the columns. So if you can organize a set of data in form of rows and columns, then you have a structured data. And we have many examples of this. For example, drilling data is structured. Log data, whether it is wireline log, whether it is mud log, they are structured. Well test data, production data, okay, and even geochemistry data, not necessarily those that are measured in the field, even if they are measured in the lab, but as long as you can arrange them in form of rows and columns, then they become structured. Examples of unstructured data include images. And here we'll talk about examples like thin section images, okay? We talk about core description images, core images. I believe that I'm talking to an audience with some basic knowledge of, geology, petroleum engineering, and probably reservoir and production engineering. So I didn't bother to go into the details of those words. And if I were to go into them, I wouldn't be able to do justice to the entire topic. So please bear with me. In case I'm going beyond an assumed level, please pardon me. And I hope you still go home with something very informative and useful. So another example of unstructured data are videos. Videos are unstructured, just like images. And a very good example from geophysics is seismic volume. Seismic volumes are unstructured data. And we also have reports that are either written or typed out, but they are in form of text. They are not organized in form of rows and columns. And something like drilling reports. Drilling reports is another good example of unstructured data. Others like borehole images, or they are also called FMI images. They are also unstructured data. So all these structured and unstructured data are managed or analyzed using artificial intelligence applications in order to solve one problem or the other. And at the end of my talk, I will be giving few examples of such applications. Now, very related to the issue of data is what is now called big data. And again, I want to open the floor for some conversation. Who can tell me what is big data? Any idea from the audience? Feel free to unmute yourself and say something. What is big data? And don't tell me data that is big. That would be too simplistic.
Okay. I think,
any volunteer? Yeah, please go ahead.
Can I come on board?
Yeah, please go ahead.
Big data, they are data that are characterized with high volume, high velocity, and high variety.
Okay.
I think 3B.
That's very good. That's a very good attempt. So basically, you're very correct. And in few seconds, I will get there. So data sets that are having size that goes beyond the ability of traditional relational databases are usually called big data. And what do we mean here? If you are using Microsoft Excel, for example, and you have to scroll down for a long time before you get to a part of your data, you are probably dealing with big data. This may not be a popular definition, but it is very relative, and it depends on the field that you are talking about. For example, in the petroleum industry, someone might be working with about 10,000 samples of data and claims this is big data. So people might say, no, 10,000 is too small. But if you have like 60,000 or 100,000, then you are working with big data. And someone from a different field, like bioinformatics, there they deal with millions of samples of data. They will tell you 100,000 is nothing. So it all depends on where you are coming from. So as our moderator has said, another way to look at big data is any data that has high volume, high velocity. That is, the rate at which they are coming into you is very high, like production data, like data from sensors, okay? Some sensors generate their data every second. So imagine getting some data every second, okay? 24 hours in a day, 7 days in a week, and all the year round. You can imagine the volume of data that you will get, at the end of the year. And also, when you have data that has, with mud gas data, with lithology data, then you might. And also, big data can come in form of structured, unstructured, either streaming in real time or coming in batch mode. They are all called big data, and they can come from sensors, come from IoT devices. They can come from videos and audios in real time, from networks, from log files, and so on, and even from the social media. They are all called big data. So, and usually, if they come in real time and in a very large scale, then all this can fit into the definition. Now, this slide is very important to me, and I hope you also benefit from it. If this is the only thing you take away from this talk today, I'll be very glad. People have been using different terminologies. Sometimes they say artificial intelligence as if it is the same thing with machine learning. And then sometimes they say neural networks. Majority of people I have found, based on my interaction, do not know the difference among all these terminologies. So I want to use this slide, and with this diagram, which I call the AI family tree. So I love it so much. Now, from AI, which we have just defined a while ago, when you say artificial intelligence, okay, you are actually referring to different areas of application. You can be talking about natural language processing, NLP, which deals with text processing, text analysis, video analysis, voice analysis, and so on. And these are applications in the area of language translation, text analysis, converting text to voice, and so on. That is NLP. So when you say AI, you could be referring to NLP as well. If you say AI, you can be talking about expert systems. These are rule-based applications, okay? Through different rules, you get to the root of a problem. For example, if someone is sick, okay, or someone has a headache, and you happen to have an expert system to diagnose what is wrong with the person, it may start with a question like, from which part of the head are you feeling the headache? Is it from the front or the back or the right side or the left side? So based on the answer to this question, then the system will bring up a new question to dig further until it gets to the root of the diagnosis. So we have expert systems for disease diagnosis and so on. Also, when you say AI, you could be referring to robotics. Okay, and just a few slides away, I gave an example of a robotic arm. So robotics also is part of artificial intelligence because they are programmed to do things that humans do. They are programmed to perform some repetitive task, and they will continue to do it without making any mistake. So that is considered a kind of intelligence. And then the fourth one is computational intelligence. This is exactly where you deal with data, mainly structured data as well as unstructured data as well. And that will be the focus of this talk. So I'm not going to speak much about natural language processing, nothing much about expert systems, nothing much about robotics, but I will be focusing more on computational intelligence. So when we say computational intelligence, this is the computational aspect of artificial intelligence. This is where you deal with data. This is where you want to convert data to information and to take the information further to creating new knowledge that will impact our life and to make our work easier. So when we talk about computational intelligence, then we talk about knowledge discovery, pattern recognition, data mining, and eventually we combine all these three to perform what we call machine learning. So very quickly, what do we mean by knowledge discovery? These are the processes that we go through to convert data to useful knowledge that goes beyond mere providing information. And as you can see on the screen, it starts from where you have your data. So you have a repository where you have various kinds of data. But in order to solve a specific problem, you need a specific type of data, or you need some specific set of data that you can combine to solve the problem. So the first step is to actually go to the data repository and select the data that you need for the specific problem, and that is called data selection. Then when you have that data, you might need to pre-process this data. You might need to do some cleaning. There might be some missing data. There might be some, some outliers. So you want to remove all these outliers. You want to fill the missing data or to remove them. So basically, you want to prepare this data. Now, when you have this processed data, you might need some transformation depending on your objective, depending on the kind of data mining method you want to use. Some method requires that the data is transformed to a different pattern before they can be used. Some don't require any transformation. So if you need to transform your data, for example, you can normalize your data, you can standardize your data, and so on. So this is called data transformation. After that, you apply any method that you want to use to mine the data. We call it data mining. So, and this depends on your objective. If you want to predict some weather forecasts, then you apply some forecasting methods or algorithms. If you want to predict some petroleum reservoir properties, you apply the relevant method. So we call this data mining. Then after doing this, you get your results. So how do you know that this result is useful? You do what is called evaluation. You compare part of the results with what we call the ground truth. If they are close enough, sometimes we can't have a perfect match. So if we are close enough based on some threshold, we say, yes, now we have a good model. And from this model, we have extracted a new knowledge. And when we talk about data mining, then we are talking about the different things that we do with data. We can visualize data. We can perform some statistics. We want to know the average, the standard deviation, the covariance, and so on. And of course, we want to do machine learning. And that is the next line in the topic. So what exactly now is machine learning? From the figure I showed you, we found that machine learning is under the computational intelligence, which happens to be the aspect of AI where you deal with data. So machine learning is the process of teaching computers to do what humans do naturally. And what do humans do? We learn from experience. So the same thing, those machines that we teach, we make them learn from experience. But what is experience to the machine is data, historical data, the data of what has happened in the past. We bring them and we give them to the machine. So the machine fits a curve around the data, which we call learning. And then from this curve, we try to infer, to make inference on what will happen next. If we have this now, what will happen? What will be the output? Okay, so it's all about finding patterns in data. I call this machine learning plus, just to summarize what I have said about the differences between AI, machine learning. So now, again, to quickly recap at this point, AI is a branch of computer science where you are handling varieties of intelligent technologies. Then under this AI, we have machine learning. Then machine learning can be divided into two. We have the unsupervised learning and supervised learning. When your learning is unsupervised, it means you only have some raw data. You don't have the ground truth. So you want some algorithms to help you to cluster the data and give you some associations from the data, from groupings, to give you some groupings. And there are algorithms that are used to do this. And when you are doing supervised learning, then it means first, you are teaching a machine about some activities using some historical data. And when the machine has been well taught or well learned, then you use this gives you a model. Then you use the model to make predictions. And this can be in two forms. It can be classification and it can be regression. Classification is when your ground truth is qualitative. Okay, you are dealing with qualities. You are not dealing with numbers. So the simplest example could be when your output is yes or no. For example, in weather forecast, maybe your objective is to predict whether it will rain tomorrow or not. So this is binary output. The answer is yes or no. Yes, it will rain. No, it will not rain. And then we can go multi-class. That is when you have more than two options. We call it multi-class. And a good example is maybe rock typing. Okay, rock typing. This is a very important aspect of petroleum exploration. You want to predict, for example, from wireline logs, some rock types, and you may have up to 5 types of rocks, ranging from clastic, you can have carbonate, you can have dolomite, you can have sandstone, and so on. So when you have more than 2 classes of your ground truth, then you are doing classification. And when your ground truth is mainly numbers, okay, continuous variables, we call it regression. So when you are predicting age, okay, from height and voice, for example, then you are doing regression. When you are predicting the price of oil, okay, if you are predicting porosity, you are predicting water saturation, then this is a regression because you are dealing with numbers. And these are the various algorithms that are used for each one of them. For clustering, you have k-means, you have fuzzy c-means, you have Gaussian mixture models, and so on. For classification, we have a whole lot of methods like neural networks, support vector machines, k-nearest neighbor, decision tree, and so on. And almost the same thing, the same algorithms that we use for classification, many of them with a little tweak, you can also use them for regression. So from this picture, now you can understand the difference among neural networks. And as you can see here, you can see neural network here being a method for clustering, another one here being a method for classification, another one here being a method of regression. So it means neural networks, along with the other methods, they are just methods that we can use to apply machine learning. And machine learning is just one of the aspects of artificial intelligence where we deal with data and we are making predictions. So I hope this is very clear now. And very quickly, this is just what happens when we say we are doing machine learning, mainly supervised machine learning. As you can see, when we are doing supervised machine learning, then we have the inputs and we have the outputs, which is also called the target or the ground truth. So we present both the question and the answer of what has happened in the past, which we call historical data. We give them to our algorithm, and then we use this to train, to optimize them, okay? And then we have a trained machine learning model. So from algorithm or from a method, you have what is called a model, and then you validate your model, okay, until you are confident of the performance. Then you can bring in some input, okay, where you don't have the output, but you actually need the output. So the input goes to the trained machine learning model, and you get the output that you don't have and which you are looking for. So this is basically what happens when we say we are doing machine learning in just one paragraph. And something to note here, the main challenge here is the learning and optimization process. This is the key here. So if you don't get the learning and the optimization process right, then you may not get the whole thing right. And I will quickly go into that now. Now, when we are doing machine learning, this is exactly what we are trying to do, okay? Now, this figure on the left side is your error, your model error, okay? The y-axis is the model error, and the x-axis is the complexity of your model. And by complexity, it means you are increasing the magnitude of the tuning parameters of your model. Now, when you start building your model, the error might be high, as we see on the left part of the plot. Your model might be high, but as you add more data, or as you increase the complexity of your data, for example, if the method you are using is neural networks, one of the parameters you can change, and one of the ways you can increase the complexity is to increase the number of hidden neurons. So when you increase the number of hidden neurons, then you increase the level of complexity, and then your error will begin to decline, okay? Now, and you monitor your model using a training data and a testing data. At the point when you see that your training data continue, the error of your training error continues to decline, but at the same time, your testing error continues to increase, then we say this is the point of overfitting. At this point, you go into what is called overfitting. So overfitting is a key problem that we are trying to avoid when we are doing machine learning. This is very important. And very quickly, some of the recent developments in the area of supervised machine learning is hybrid learning. And this is nothing but, when you combine two or more existing methods, you combine them such that you make one to overcome or to override the weakness. You use the strength of one to compensate for the weakness of the other one, to give you a robust model. Then we say that you are doing hybrid learning. And a very good example is this method called ANFIS, Adaptive Neurofuzzy Inference System. It is actually a combination of neural networks and fuzzy logic. So this is a good example of that. So as we can see, it starts with fuzzy logic and then it ends with neural network. But both of them are working together as a single entity, and we call this hybrid learning. Also, we have ensemble learning. This is basically when you apply either different methods on the same problem to give you different outputs, or you apply different versions or different instances of the same method to solve the same problem. That is, you apply them on the same data and they give you different outputs. Then eventually you combine this output in a way to give you only one consensus output. And a very good example of this in real human life is what is called, when we have a committee okay, you have a very strong issue that you want to resolve. For example, maybe in a university, you want to decide whether to let students use, to conduct their exams online or to do it in person on paper. And then people are people are bringing different opinions. And then you say, oh, okay, let's form a committee to look into this for us. So you have 10 people in a committee. And what do they do? Each one will bring on the table his or her experience. And then the chairman of the committee will combine all this experience, all these opinions, to make a single recommendation to the university management. So the same thing happens here. And a good example of this is the random forest, okay? Random forest, and that's why it's called a forest, because it is composed of several instances of decision tree solving the same problem. So each instance produces one output, which are later combined by some algorithms to give a single output, which we call the ensemble output. And also beyond hybrid and ensembles, we also have what is called deep learning. Here, I will not go too deep into that. Deep learning actually comes along with big data, and it works mainly on text, on audio, on images, and on videos. So this is just to give you an idea of that. So for example, an example of a deep learning model is a convolutional neural network. So you have the network here in the middle, and you train this model with different types of objects, different shapes of aeroplane, different shapes of automobile, different shapes of birds, different shapes of cars, and so on. So here you are building the model. Now, when you have a trained model, then you can show an image, an object to the trained model, then it tells you what it could be, okay? And since things look alike, but with different degrees, it will give you, an output with different degrees of accuracy, and then it will indicate one as the most probable. Like in this case now, if you show the model, the picture of a dog, somehow there might be some features of a dog that are found in cats or birds or boats, okay? But most probably, this is the picture of a dog. So the same thing happens to a cat as well, and so on. So this is just an example of deep learning. So to bring them side by side, what is the advantage of deep learning and shallow learning? Deep learning is when we are learning with big data, and shallow learning is when we are learning with small data, or the other way around. Deep learning is when we are working with a highly complicated model, and shallow learning is when we are learning with a very simple model. So in deep learning, the advantage is that as you add more data and you increase the complexity of your model, your accuracy increases. But for shallow learning, it gets to a point where there is no more improvement. So this is the main difference. And I don't want to spend more time on summarizing. So now, this is another important part of the talk, which is actually very useful. It is when exactly do we use machine learning? When do we use it? So people believe nowadays that you can use machine learning everywhere, anywhere. Some people believe that it is like a magic wand. Okay, if you have a problem, just bring machine learning and it will solve it. That's not the case. There are some instances where you need machine learning, and there are some problems that machine learning cannot solve, or that are not necessary to solve with machine learning. So, and some of the instances where we need machine learning is, for example, when there is no rule, when there is no existing rule or existing equation. And I used to give this very funny or simple example. it doesn't make sense for someone to say, okay, I want to use machine learning to predict speed. Okay, so my target is speed, and my input will be distance and time. We say this is unnecessary because there is an existing equation to do that. And the equation is universal. It is, it works everywhere in the world. Okay, we all know that when you divide your distance by time, you get speed. So you don't need machine learning for this at all. Also, even if there are rules, but the rules are too complex to comprehend, then we can say, okay, let's use machine learning. For example, if you have an equation, and my typical example here is the Arsh's equation. If you are a petroleum engineer or a reservoir engineer, you will know what is the Arsh's equation. It is the equation that is used to estimate water saturation, given inputs like porosity, like resistivity, saturation factor, and so on. So this equation was derived from very complex scenarios, but it was eventually simplified by bringing in various assumptions. So in that case, we say, okay, if you bring in too much assumptions, then the equation becomes unreasonable. So why don't you use machine learning in this case? So this is and yes, this is the equation here. Okay, so this equation, as simple as it looks, has a lot of assumptions that go into it to make it look very simple. And also, when you have rules, they are not only complex, but they are only constantly changing. They are not constant. They are always changing. Then that is when you can apply machine learning. And also, when the nature of the data is not the same, it is changing all the time. For example, you get data from carbonate rock, you get the data from clastic rock, from dolomite. You cannot, derive a single equation that will work in all the different types of rocks. No. So if you have to combine them, then machine learning is, it is possible to build a machine learning model that will be able to predict irrespective of the rock types. And of course, when you have a large amount of data that you cannot handle with this kind of equation, then you use machine learning. Now, what are the opportunities that we have nowadays to apply machine learning in petroleum exploration and production? Very quickly, of course, the fourth industrial revolution is the #1 opportunity that we are having today. Without it, we won't be talking about AI or data science. So first of all, this is an opportunity. And then today we have a lot of data. The industry generates a lot of data nowadays. So it's giving us opportunity to apply machine learning to handle this voluminous data. And also, with focus on digital transformation, we want to utilize real-time data. We want to use data that comes while you are drilling without waiting for, any weeks, any days, any months, any year. You want to maximize the use of your data. This is an opportunity. Also, we have been suffering from the downturn in oil price over some years now. And this is actually giving companies the opportunity to utilize machine learning and other technologies to reduce their operational expenditure in order to keep, oil production going. So companies nowadays, they are developing technologies like never before, and they are utilizing existing technologies to reduce their costs and to maximize their profit. An example is Apache and also in drink. So companies nowadays are utilizing data in order to reduce their, to address their challenges, to reduce non-productive time, to reduce drilling problems. Okay. algorithms are being used to leverage abundant seismic data. So now companies are developing technologies that will make job easier, more accurate, okay, less expensive. And this is creating opportunities for students and young professionals in the field to, to leverage on their innovative thinking, their critical thinking to contribute to technology development in the industry. And you guys have a big chance to go into this area. And also the pandemic that we are still, suffering from is another opportunity. So in all these challenges that the industry is facing, technologies have roles to play in them. And that is why I encourage each and every one of you to chart a path in any of these four IR technologies: virtual reality, 3D printing, robotics, big data, machine learning, AI, and so on. And applying all these technologies will transform various, industry operations and make them more accurate, to decrease the risk in them, to increase safety, to provide real-time data, to increase revenue. And that's really very important nowadays. So very quickly, I've spent beyond the time given to me just to give you a taste of what technology has been used to accomplish in the oil industry. For example, in the area of seismic, okay, we all know how seismic is done, how the data is acquired, how it is the process, and how it is interpreted. Nowadays, machine learning is playing a big role in this. For example, in the seismic data acquisition, the geo drones are being, launched nowadays with drones. Drones are being used now to do seismic data acquisition. A lot of algorithms that use machine learning in the background are being used nowadays to analyze or to process seismic data. Now humans no more look at seismic traces and then be looking for first breaks, tracing lines. No, algorithms are doing the work and not necessarily replacing the humans. Humans still remain at the center of this technology. And in geology, usually geologists go to the field, okay, to inspect outcrops, right? Nowadays, drones are being used to map these outcrops and then digitize them using photogrammetry technology. So basically, it is possible nowadays to bring the outcrop from the field right on the geologist desktop. Okay, on the geologist now have the outcrop on his or her desk, as we can see in this in the third one here. This is an outcrop that has been digitized. So now a geologist can actually zoom in and zoom out and look at and do everything that will have been done on the field, spending money, spending days, and so on. Another example is the core description. Okay, we all know how core samples are being described by geologists, as we see on the left. Okay, it's a qualitative process which is highly subjective, but with advanced image analysis coupled with machine learning, we can actually digitize this process, and then the machine learning will give us an automatic description of the core samples depth by depth, or according to based on our zones of interest. Also, we have the thin section analysis coming from geology application. Now, conventionally, we have a geologist looking at them under the microscope, but nowadays they are being digitized. So taking advantage of the photographs that are taken from the microscopes, advanced image processing algorithms are combined with machine learning to do automatic interpretation of thin sections. Also, we generate logs of, we can use machine learning to generate missing logs, okay? And logs that are traditionally few points, we can actually use machine learning to generate a lot of them to fill the gaps that we have in our reservoirs. And also instances where we have some logs missing due to tools failure, due to human errors or whatever, machine learning can help us to fill those gaps, to generate those missing sections in our logs. All these are the various applications. And also nowadays we are talking about possibly having real-time reservoir characterization. And how do we achieve that? Instead of using wireline logs to indirectly estimate various reservoir properties, now some effort has been made to use some real-time data, such as drilling data or mud gas data, in order to do the same thing in real time. So now it might be possible in a very short time to have porosity estimation while drilling, probability estimation while drilling, and so on. Even grain size estimation while drilling, ahead of core description and thin section analysis. So these are a few of the successful use cases, and very quickly I will go into the challenges that we're having. As I said earlier, there is no new advancement without its own challenges. As good as machine learning is today, there are still challenges that we are still facing. One of them is that to do machine learning will require a substantial amount of data. You cannot just have few data points and say you want to do machine learning. It will not be very efficient. Also, the learning process requires some degree of expertise. That's why if you want to go into machine learning, you have to get yourself trained. Training is very important. So get yourself trained and then make your hands dirty with real applications. Also, people are complaining that domain experts, especially in the oil and gas industry, they are reluctant to accept machine learning because they say, well, it's a black box. You don't know what is happening inside it. Well, even though it is true to some extent, but as an expert myself, I say, well, if you are really interested in what goes on inside a machine learning model, you can actually know it. It's a combination of mathematics, statistics, calculus, algebra, and so on. So it is not completely a black box. Also, the domain experts say that, well, how can I trust your model when it focuses on the pattern in data and not the pieces of the problem? Well, in this also, as an expert myself, I say, well, that's not really true. The data is a representation of the physics of the problem. So therefore, the models are actually reading the physics from the data. Okay, that's the way that I try to convince my clients. And also, one of the things that we are facing today is that data scientists, they lack the fundamental knowledge, okay, of the algorithms. And this actually happens to some people who just go online and do some 3 weeks course, 3-month course, 6-month course, and then they say, now we are experts. Well, even though that is good, and I do encourage people to go online and take some of those courses, you still need to go to the foundation of those algorithms, read about them, know how they work, and then be able to convince your clients on how the results that you have are obtained. So coming to the end, I would like to give you the following takeaways. Invest in massive data acquisition. Nowadays, you'll be surprised that we will think that there is data everywhere. Majority of, in some places, we still don't have enough data. So we have to invest massively in data acquisition. We have to get more data get more data. Since machine learning depends majorly on data, so we have to get more data in order to get good results. Also, we have a lot of data, but majority of them are not of good quality. So we have to invest in data quality assurance. Also, we have to seek, the foundational knowledge of all these machine learning methods. We can whiten the so-called black box. And also, we have to work with experts, okay? We have to work with experts. For example, a computer scientist who knows nothing about drilling may find it challenging to solve a drilling problem. So you need to work with a drilling engineer. So you are coming with your machine learning knowledge, and then you sit with an expert in drilling engineering. Then the two of you sitting together, brainstorming together, will come up with a better result than if you alone just focusing on the data and you are just, applying your algorithms on the data without having a strong knowledge of the problem area, of the problem domain. That's very important. And also make solutions very easy to use. Nowadays, it is not just enough to build a model. Sometimes you need to build a software around the model so that users can interact easily with the solution that you are providing, because they don't really need your code. They don't need your code. So you have to design a very, enticing, attractive user interface to hide your code, and then let your users focus on the solution rather than focusing on your code. That's very important. And also, instead of having pockets of solutions here and there, we should rather combine those that can be combined to form a suite of solutions. So, for example, in the example of Archie equation I gave earlier, actually there are 3 parameters in that equation. You have the A, which is called tortuosity. You have the N, which is called saturation index, and you have the M, which is called saturation factor. Instead of having different models to predict each of these A, M, and N, it would be far better to have a single solution that predicts A, M, and N, and then plug in the output into the equation, and the same suite of solution will give you the water saturation all in one. This will be far better than having individuals. And on the final note, I will encourage each and every one of you. I was made to understand that most of my audience, some are students, some are young professionals. You need both hard and soft skills, okay? Hard skill, AI, machine learning, robotics, blockchain, and so on. You also need soft skills to make the hard skills become, more beneficial. You need to be able to think algorithmically, okay? You should have this problem-solving mindset. Also, you should be able to manage your projects very well, and very importantly, you have to be resilient. So that's very important. That is, you have to be, you have to be innovative. You have to have the critical thinking, innovative thinking, in order to bring solutions to address problems. So I would like to conclude here. I'm sorry for taking some extra time, and I will stop it at this point. I'll be glad to entertain your questions. And in case you want to contact me, feel free anytime through any of these means. I'm on ResearchGate, I'm on LinkedIn, and you can also feel free to send me email. So thank you very much. I'm back to Mr. Moderator. Mr. Moderator, are you talking?
Thank you. So,
okay.
Dr. Fatai Anifowose, we really appreciate the lecture you just delivered to us. As we said earlier,
I think you have a very poor network. Your voice is getting distorted.
Can you hear me? Am I audible enough?
Yes.
Okay.
Now it's better. Yes.
Okay.
Now it's better.
Okay. So we thank Dr. Fatai Anifowose for the beautiful lecture. And before we go further, I will want to quickly introduce the institute to those of us that we may be new to the institute. So the institute is named.
We can't hear you anymore.
Can you hear me?
Your voice is getting distorted.
Okay. Can you hear me? Hello? Can you hear me?
Yes, but it's breaking actually.
Okay.
It's breaking.
Okay. Okay. So as I was saying, I said I want to quickly introduce the institute to those of us that we are new to the institute. The institute's name is Institute of Data Science and Artificial Intelligence. Here in Nigeria, our focus is to provide a platform to synergize across different disciplines. As you can hear the expert speaking, the people from the background of mathematics, computer science, information technology, software engineering, that they are at the center or at the core of artificial intelligence, data science, machine learning, and what have you, they cannot do anything because really, AI, they are just tools. AI systems are tools. Machine learning, they are tools in the hands of these people that learn how to use these tools. But how should they use it? What problem should they use it to solve? They need the knowledge, and they cannot be expert on the tools and yet be expert on different domains where those problems are to reside. So it is a global problem for us to really have a platform where different people can come together and interact, and it will be easy for these people at the algorithm level, at the statistical method level, to be able to understand the problem at hand and solve the problem accordingly. So the institute is a professional body, is a research-enabled platform to create multidisciplinary synergy to deploy AI and machine learning systems or handle integrated data services, as the case may be. So for now, we are focusing on public awareness. We are focusing on raising the phobia the public may have for change. If people hear machine learning, they tend to be fearful of what it will mean, what is the aftermath. And thank God, this word at the industrial level, it has been bubbling around for around a decade now, if not more than. And we have seen successful application of machine learning, artificial intelligence, and how it has grown the efficiency of business processes across various sectors. So on this note, we are using this platform, this webinar that we call Chat with Experts. It is a monthly webinar that is dedicated to raising the awareness of people. Is when people, they are aware about what this paradigm can offer. That is when they will be willing to collaborate through with the institute to solve crucial problems. So I will be posting our contacts, our links, the website, the LinkedIn page, and also the number you can call for the to know more about the institute. For now, we are more focused. We are focusing on raising public awareness. and collaboration. We don't want to focus too much on acquisition of membership, because if you go by acquiring member now, but the people, they are yet to even understand what this new paradigm are, we will end up just adding accolade to people's name, just like title, without actually grooming them on how they will solve a serious industrial problem, or perhaps how they can join in the initiative to bridge the gap between the industry and the academia. Thank you. I will encourage our participants. Feel free to ask your question directly, because this is what is requested from the that is requested by the speaker. He wants to engage with you directly, so you can unmute yourself if you have a question, and then we can make this go in a more interactive. Thank you very much. If we have any question, please feel free to ask.
Good morning, Mr. Fatai. Good morning. Can you hear me?
Yeah, we can hear you.
Yes, I can hear you.
Yes. So my question is about structuring data. So for now, currently, challenges I am facing include like the data itself, the collection process itself is not structured. So would you say that you have to think from the inception stage of where you are pulling the data from and arranging it in like a template format so that you get it in a particular way that you can now use to run better analysis, or you should just focus on cleaning it on the back end, or what is the best workflow particularly you advise?
Thank you very much, Mr. Sidney. It actually depends on the nature of the problem, then the nature of the algorithm you are using to solve the problem. Certain algorithms require certain data to be in a way, to be presented in a way. So, for example, as I mentioned during the talk, if you are doing deep learning, okay, where your inputs are images or audio files or video files or text files, so you don't need to structure this kind of data, because the algorithm itself is okay with the unstructured nature of the data. That is the traditional way to present the data to the algorithm. So there's no need. However, if you are doing predictive analytics, and you are using algorithms like neural networks, like SVM, random forest, that require the data to be in a particular form. For example, all these methods, okay, they handle data like a matrix, okay? So they want the data to be in form of rows and columns. So in that case, you have to really obey that rule. And the way to do it is really very simple, because usually when you read your data, in most algorithms, data are read directly, even like a matrix. Okay, so after that, you begin to analyze, identify, and then remove outliers, identify the missing points, missing data, and so on. Because even the outliers and the missing data are really part of the matrix. Part of the initial matrix that are read directly from the input medium. So yeah, in summary, it depends on the nature of the problem you are solving and the nature of the algorithm you are using to solve the problem. I hope I addressed the question sufficiently.
Yes, you did, sir. Yes, you did.
Okay. Thank you. Yeah.
Okay. So there is a question here.
Okay.
That, does programming language matters in building an AI?
I would say it doesn't matter. I mean, if I understand the question correctly, I think the question is asking if a specific programming language is required for machine learning. So the answer is no. You can do machine learning using any programming platform. You can use MATLAB for machine learning. You can use Python for machine learning. You can use R for machine learning. You can use even, I've seen people using C++ or even Fortran for machine learning. So the programming language doesn't really matter. What matters is the algorithm.
Okay.
So I hope I answered that. Yeah.
Please. Any other question? As you can see at the chart at the chat section of the screen, I've posted using my personal account, Abduaid Yusuf, the website for the institute, the email for the institute, and also our LinkedIn page with the number that you can reach us on if you need further clarification or you want to know more about the institute. As we said earlier, sooner membership acquisition will begin, but our focus is we want this institute to be a solution center, where when we are discussing about conferences, you are coming down to tell us what problem you are solving. So we want to be we are looking at applied AI, applied data science. A lot of theories are available already, but the problem we are having is that awareness across other disciplines are very low, to the extent that if people they could understand these fundamentals or the basic philosophy behind data science and artificial intelligence, they go ahead and apply the simplest algorithms to solve their data, it will tremendously improve their business efficiency, and they will be able to solve a lot of crucial problems, save a lot of resources. So this is our goal, this is our target. So I think Mr. Sydney is raising up his hand. So please, you can ask your question directly.
Yes, I still have a couple of questions. I have two questions, Baskan.
Please go ahead.
Yes, Mr. Fatai, so do we have any open data, open source repository for petroleum data sets, or most of them are closed source? That's like my first question.
Yes, there is. I'm trying to recollect where I got a link from, and the link was said to be an open source data repository. I think I will find that out. I've already seen you on LinkedIn, so I think we will be communicating from there. Yes, there is, and as I said, I will find out that link. I saw it somewhere, I can't remember. Then what is well known now is there is this company in the North Sea called Equinor in Norway. So a few years back, they actually released some data to the world. It is called Volve data sets. So even if you search on Google that you're looking for Volve data set, I'm very sure you get the link. So I heard that the data set comprises from seismic to petrophysics to production. I mean, all what you. So I will encourage you to just search for Volve data sets released by Equinor, and then you will find it, I'm very sure. And then I will try to look for the other one that I found somewhere. Yes, there is available.
Second question, sir.
Yeah.
Your experience, because most of
please, I want to add to what Dr. Fatai just said. Regarding open data sets, you see, gradually people will begin to understand the concept of data democratization, because people, they think that when they share their data, they are releasing their business secrets. But little did they know that there is what we call, there is a way we can actually protect their data by encoding the data to develop machine learning model, or to obtain some interesting analytical results without actually knowing the fundament, I mean the main values of those data. So we will try to encode the data, and we will process the data will be modeled, and the result will be presented. Then at their own level, they will decode the data, because when they are delivering the data to the public, the data is already encoded. So I think it is the problem we are having, and the problem we are having is lack of awareness. And the oil industry, they are coming to the scene very lately. They are coming to the scene. Please hold on. Okay, sorry. So they are coming a little bit late to the scene, and as time goes on, we are going to know more about this open data set, because it is the philosophy that is the challenge to the people for now. They fail to understand the philosophy, and we've seen how people are using it tremendously. And I hope that in Nigeria, we will also adopt this also. I want to add to an open data set that I think you may play around with if you have the required computation resources. Perhaps is if you go to the SEG, WikiSEG, that is Society of Exploration Geophysicists. So SEG, so they are WikiSEG, Society of Exploration Geophysicists. There is a particular data set that was released late 2020 on on seismic fascist classification. So I think the data was released to SEC by Chevron USA. So you can also get your hand dirty on that. Then on the issue of programming language that you can use for AI, I think there are some paid platforms that you can use to deploy your AI, just as if you are using your Microsoft Word without having any coding knowledge. And I think all these platforms like IBM, they are doing well. Also, likewise, there are some open source, also MATLAB. Also, we have some open source software that you can also use without even know much code, like Orange. So just get yourself close to the institute. Soon we are going to start our training, and more awareness is coming. We are just only facing our focus in this our discussion, the application in petroleum exploration and production, which is on the petroleum upstream. We still have the midstream, we still have the downstream. This is just the oil and gas industry alone. We have not been talking about the environment as a subsector. We have not been talking about the medical domain, healthcare delivery. We have not been talking about surveillance. We have not been talking about forensic or forensic science. So these institutes, we are trying to take this philosophy and deliver it to these domains, and let them also come on board to the institute, and we discuss how maybe in few years to come, Nigeria also can be at the front line discussion of digital technology, digital economy, as this government, they would rather want to brand their involvement in the ICT sector. You know, they just name it Ministry of Communication and Digital Economy. So thank you very much for your time. Please, you can go ahead with your second question.
Yeah, yes, sir. So my last question is, all the examples that you have shared so far are mostly on upstream exploration and mostly oil. Are there any projects on natural gas and things like, just particularly gas, natural gas, liquefied petroleum gas? Is there any analytics happening on those kind of data sets? And in your experience, have you heard of things like that?
I'm very sure there will be. Unfortunately, I couldn't bring examples from that sector. Actually, what I have shown here are the projects that I have been involved in at one time or the other. So I'm not a fan of, going to the internet and then bringing some vague examples. I like to bring my own example. So that's why. So this is perhaps a limitation in my scope of application, but something very close to what you are asking about, and which I showed, is actually using mud gas data. I know that it's not exactly what you are asking for. You're asking for, applications in a gas producing field, right? But part of what I showed, I mean, the last one in particular, was the one that is being proposed for possible real-time reservoir characterization. Because when you are drilling, okay, and you get to reservoir section, gas is released from the wellbore, and this gas is captured at the surface and separated. So you have the methane, the ethane, the propane, the butane, and so on out. So from the measurement of these gases, you can actually link them up with certain reservoir properties like porosity, permeability, saturation, even rock type, and so on. Because different rock has different density, and hence they will liberate different quantities of gas. So that is the correlation that we are trying to discover there. So yeah, in case I'm not able to bring that example, I'm sorry, I couldn't lay my hands on them. Yeah, but I'm very sure there will be, successful use cases in that area as well.
Thank you very much, sir. Really appreciate it. Yes.
You're welcome. Yeah.
Any other question? Any other question? Okay. So in the absence of no question, we are saying big thank you to Dr. Fatai Anifowose. We hope that we see you more on this our chat with experts, because we are trying to go from general to specific, and as time goes on, we are going to be having domain-specific audience that have a particular, some defined workflow within the upstream sector. So we hope that you will be kind enough to answer our call whenever we call you. Thank you very much. As you can see, he's sharing his details on the screen for direct contact. So please feel free to contact him. Thank you very much. We really appreciate your kind gesture. For the participants, also, I've shared with you on the screen, on the chat, the contact details of the institute. Feel free to contact us directly. If you need more information about data science and AI generally, feel free to send in your request. We are always available on board. This is a solution center that we expect everyone that is interested to collaborate, and we can at least see how we can use AI and data science technologies to improve the life of the commoners, and also increase our own career as we do that. Thank you very much. We really appreciate your coming. Have a